Hello guys, in this video I'm going to show you how to solve quadruple sum to target. So given an array of unsorted numbers and a target number, find all unique quadruplets in it whose sum is equal to the target number. So we're given an unsorted array and a target sum. Our goal is to find combinations of four numbers that sum up to target, right? So in this example, we can find two quadruplets that sum up to 1. You can see, right? Minus 3 minus 1 is minus 4. Plus 4 is 0. Plus 1 is 1. Okay, same here. This will sum up to 1. Okay, so this one is very similar to our previous problems, which are two sums and triplet sum and two sums, right? So the approach is pretty much the same. So let's uh, let's uh, let's try to remember the two sum problem, right? So for example, this given array. So for example, if I want to find a two sums that sum up to let's say 3, two sum and target a 3, for example, right? So because we need to find two numbers, right, that satisfies a constraint which is sum up to a target. So we could the maybe the easiest way to just check um, all the all pairs of two numbers and check sum if it's equal to target, but it's gonna be a n square approach, right? So it's not very good. So one way to reduce mm, the amount of time complexities is to first sort it, right? So we have minus 1, 1, sorry, minus 3, sorted in ascending order, 1, 1, and 2, and 4, right? So by sorting it, so after the array is sorted, we can take advantage of this sorted array uh, to check the sum of two numbers. Right, for example, because it is sorted in ascending order, so we're gonna check two pairs here. We're gonna first check the sum of the first and the last number, right? And depending on its sum compared to the target, we're gonna know uh, what is the next pair we want to check. For example, minus 3 plus 4 is 1, which is less than the target. So we need a bigger number. So in order to get a bigger number, we're gonna move the left pointer rightward because it is sorted array, and moving the left pointer rightward will give us a bigger number, right? And if we need a smaller number, we're gonna move the right pointer leftward, right? So taking advantage of sorted array, we can reduce the term. It's not going to be n square anymore, right? So let's just keep checking here, right? So let's do it with two sum here. So okay, the current sum is 1 less than 3, so we need a bigger number. So I will move left pointer onward. Okay, so now pair is -1 plus 4 is 3, which is what we need. So I just save it into the final array. -1 plus 4, 4. Okay. So for the next step would be to make sure that two next number is gonna be totally different than the the, the previous numbers, right? The next pair is gonna be 1 and 2, right? So 1 and 2. Okay, 1 and 2. Okay, 1 and 2. 1 plus 2 is 3. So we have another valid pair, 1 and 2, right? So because same idea here, we want another pair that is different than the two previous pairs, so we just move the two pointer ahead, right? Uh, let's move the left pointer first, right? This guy. So after moving the left pointer rightward, as you can see, uh, it is 1, which is equal to its previous number. So that it's when this is the case, that the current number is equal to its previous number, it we are sure that it's not gonna add up to the it's I mean it's still it's the same as the valid 1 plus 2 here, right? So the idea is to keep moving the pointers so that we have a different number on the left and a different number on the side right. Okay, so the next I will just keep moving left pointer rightward. So now, as you can see, two pointer meet at one point. So this is the time we stop our algorithm, because two pointer with two pointer we cannot find pair, right? So two pointer at the same number we cannot find pair. of two numbers. So we stop here, and here's a two sums problem, right? So just to remind you, because if you can solve the two sums, then the three sums and the quadruplet is pretty much the same, right? For three sum, when the idea is that when I fix one number, right, and when I take the target minus the fixing number, then when I have our problem will come down to the two sum problem, right? We take the current number out of the target sum, and our goals is to find two sums, two numbers as sum up to the target, right? And for the quadruplets problem, like assuming that we know how to solve triplet sum, same idea, want to fix one number, right? Want to take that number out of the target, then want to find amongst the remaining number a triplet that sum up to the new target. So later want to combine, if we can find a triplet, want to combine the fixing number with the triplet that sum up to the target. So long story short, let's get into coding now. Okay, let me see. Okay, the first thing is to sort the array first. Sort array in ascending order. Okay, array sort A in B. Ascending order, so it will be A minus B. Easy. Okay, so next is to fixing one number, right? So let's say first index equal to 0. First index, let's write the length. First index plus. So first index will be the index of the number that we want to fix, right? Okay, so the first number here is going to be, let's say, first number will be array dot first index, and our goals now is gonna be find the triplet, sub triplet, right, from the array, from this array, from index first index plus 1 until let's say array. Do we need the last index? No, we just need the left index, right? Okay, the target, the next argument will be the target of the triplets, so it would be the current target of quadruplets minus the first name. Okay, this will return for us the chiplet, all the chiplets. So let's say I'm gonna store the final result into quadruplets. It is an array. Finally, I return a quadruplet. So here, for each chiplet that is returned from these functions, I'm gonna use for each, right? It's gonna be an array. And here, with each chiplet, I'm gonna build a quadruplet by combining the fixing number here with the chiplet to form a quadruplet and push it into the final result. Quadruplet push. Then array, I spread the first num, and the chiplet here could be in 3 numbers, so I will spread it out. Okay, awesome. So now our task now is to find to implement the search chiplets. So here is same as the previous problem in this category. Okay, the first argument is array. Is the next is a length boundary. Right, start index. Let's say, because when search from the start index all the way to the last index, so we don't need to pass in the last index because I'm gonna take it from the array here. Okay, so the next E will be the target, right? Wait a minute, because here we fixing one number, right? So in order to find a chiplet, we need at least a range. We need to be sure that the search space will have at least 3 numbers, right? So how want to be sure that we have 3 numbers? So after fixing the one number, the so I don't want to run all the way. I don't want to uh, iterate from index. For the first index, I don't want to iterate from index 0 all the way until the end. But I want to make sure that except for this first index, I need another 3 numbers. So it's gonna be, to make space for 3 numbers, it's gonna be the first index will run from 0 to make sure that I have 3 other numbers. It's gonna be -3 for the last index of the first index. So it will run from 0 to this boundary, right? In order to make sure that we have okay. So here sub triplets, right? Already sorted now. So let's say triplets. So the ideas is the same, right? Triplets, return the triplets. So again, let's say I wanna fix the second index will be from start index all the way until the end. Second index less than array dot length. Second index plus plus. The same idea here to make sure that we except for this this number, which is second num, will be array at second index. Okay, to make sure that except for this number we have space for two other numbers. So I'm going to run from the starting to array.length minus 2. So the last index will be array.length minus 3. Okay, so here the second number, we need to find two other numbers, right? So we could do the same like this, and like we abstract into such two sums here, but it's gonna be too much functions, so I think wanna wrap the logic of two sum inside this subtriplet. So here we're fixing the second num, right? So wanna search from the remaining space, which means from the right of second num all the way to the end. So it will be let and let will be to signify the range of two sums. It's going to be the let will be second index plus 1, and the right would be array the last index minus 1, because we need two other numbers, so we need a pair here, right? So make sure that left is less than right. Okay, so cons the two sum target will be the target, the triplet minus second num, which is the number that we have fixed. Okay, as long as less than right, Actually, we don't really need this one. Let's just so the current sum, right? I need to find the current sum. It will be second number plus array at index left, which is a third number, and array right, which is a fourth number. So if the current sum equal to the target, then this is gonna be a valid quadruple, valid triplets. If it's the case, I will push put into the triplets three numbers. First one is the second one, array left. The last array at index right. Okay. Else if current sum is less than the target, I'm gonna move because current sum is less than target, we need a bigger number, so I must move the left pointer right by incrementing left by 1. And else is the case current sum is greater than the target, so we need a smaller number by moving the right pointer left. Okay. We're not done yet, because here in the case we find a valid three sums. We here, if we do nothing, if we don't update the left and right, it's gonna get into an infinite loop here. So we need to update left and right. So because we want a totally different two pair, right? We want a totally different number on the left and a totally different number on the right. So to do so, I first increment the left first, and then decrement the right, but this will not be enough, right? Like for example, like this guy, for example, 1. Now we don't care about the number in between here. Like for example, our target is 4. So as you can see, we're at the left here and the right here, right? So 1 plus 3 is 4. So here is a valid pair. So just by moving the left pointer backward is not enough to make sure that we have a different pair, right? So after the increment the left, I need to check, right? So as long as the array at left is different than array at left -1, right? So as long as here's the previous left, right? Here's the current left. As long as the current left is still equal to the previous left, Then we need to keep incrementing the lab by 1 until it's different. For example, 2 in this case. So now we are here. We compare it with the lab minus 1, which is here. It's still equal. So I just keep incrementing the lab. So now number of lab is still equal to lab minus 1. So keep incrementing. So now it's different. Lab is different than the lab minus 1. I will exit. Look here. The same for the right. So first decrement the right by 1 and make sure that the current right is, and if the current right is still equal to its previous, which is right plus 1, then we keep moving the right level by decrementing by 1. But we need to check another conditions here, which is the left is much less than the right, and here also the left much less than the right. Okay, I think done. Let's run a test. Just 2. All right, it worked right on our first shot. Just to double check. Okay, awesome. So that is it for quadruple sum to a target using 2 pointers pattern. So thanks for watching. See you in the next video.